Hey, all right, and welcome to John Park's workshop in a very special and weird time. This is normally Ask an Engineer, and I have failed you totally because I did not dye my hair pink or grow a beard with the cool stripy badger parts like PT. So if you're expecting to see a little more in PT right now, it's not going to happen, I'm so sorry to say. But they are out of town keynoting an event, so I am taking the opportunity to do John Park's workshop on Wednesday, not Thursday. So I won't be on my normal show tomorrow at Thursday. So don't tune in then. I won't be there. First of all, I wanted to thank you all for coming out. And also I wanted to thank those of you who came out yesterday for the live unboxing of 007. Sorry, let me adjust my... Hey, there I am. It was a lot of fun, and the videos are up now if you want to go check them out, as well as lots and lots of guides in the Learn Guide. We have a lot of tutorial for the AdaBox 007, lots of tutorials. And we're also seeing a lot of people on social media who are picking locks now, which is super awesome, very exciting. I haven't seen people with their tattoos yet. Look, I got my double Blinka tattoos. Those come in the box. Those are temporary tattoos. I didn't get some tattoos. And so we're going to go over one or two of the guides that we didn't have a chance to get into depth on for the AdaBox 007 yesterday. And in particular, I wanted to go into the very mischievous, very subversive projects that use the Gemma M0's ability to act like a USB keyboard or a USB mouse on any computer you plug them into. So let me pop up for a second here the guide. So here's AdaBox 007 guide. And if you look on the left-hand side here, we've got tons and tons of them. This one right here, SAR Tuning Knob. This one right here, the Foul Fowl Keystroke Injection Attack Tool. And this one, the Phantom Mouse Jiggler. Those three all have something in common. And what that is they can use the Gemma as if it's a keyboard or a mouse when they get plugged into a computer. So the idea behind this is that since the computer sees a keyboard get plugged in or a mouse get plugged in, it really doesn't question that. And this is a really interesting security gap, really, in most computers. I actually be kind of curious for security people out there, IT people, if you do use software to prevent new keyboards from showing up. I assume there's an identifier on a keyboard or a mouse, but I'm not certain about that. Anyway, in the projects that do this, I've never had a problem plugging them in and them being accepted by a computer, and I've done this on Linux, Mac OS, and Windows computers, and they all just accept the fact that, hey, here's a keyboard and someone has started typing. So I'm going to grab this one right here is the Gemma that I put into some heat shrink so that it looks a little more discreet if you're trying to sneak it onto someone's computer. And we have our short little USB cable on here. I'll plug that back in. You can't use the on-off switch anymore with this one, but you can feel the reset if you need to reset that for some reason. So let's actually go back a page, and I'm going to look at this one first. So this is the project that I call the Phantom Mouse Jiggler. And so here's the guide for it if you want to look at it. And this one I coded with Make Code. So a lot of you are probably familiar with Make Code. It's created by Microsoft. It uses Blockly as the user interface. Let me scroll down and see if we can see the UI on here. I've got some screenshots. So that's what it looks like. These little blocks get plugged together to create the logic of your program, and then you upload them to the board. The original use for Make Code was on the Circuit Playground Express and on the Microbit, and I think one other board whose name I can never remember, but someone tell me if you remember, someone in the chat. Recently, Microsoft has put into beta this new version, which is called maker.makecode.com, and that one allows you to, let me just go to it right here, you can see it for yourselves. That one allows you to, oops, okay, so there's the regular Make Code, our good old friend Make Code, maker.makecode. This is the beta, and as you can see here, there's a whole slew of other boards that we can use now. So not just the Circuit Playground Express, but now a Metro M0 Express, Trinket M0 Express, Feather M0 Express, there's our Gemma, some Arduino boards, Maker and Zero, some Spark Fun boards, the Red Bear BLE, and they're probably adding more as they go, and I think you have a way to add your own boards. So if I click here, let's say on an Adafruit Gemma, I can say I'm going to create a new project, and when you, let's see if I can make this big enough. Yeah, okay, so we can see here's the little simulator down at the bottom of the Gemma. When you look on the side here, you have some pretty common things like checking for inputs, writing pins to high, lighting LEDs, that sort of stuff. So here we can say, if someone presses a button, what happens? So how about, okay, we'll use one of the capacitive touch sensors. And you'll see now the little icon turns into this little breadboard. This is pretty cool. It's not necessarily the ideal circuit. Some of them will end up being a little strange. It's new and it's in beta. It's worth checking out. We'd like people to get in there and hammer on it. But the idea is this is now expecting a touch input before it does something else. Let's say set a pin 0 to high. So the capacitive touch sensor would set that pin to high. Maybe you've got an LED on there. So this is how you use Make Code in general. Nothing has changed really there. But on, whoops, let me delete this. There goes a plane. And on the advanced section here, we can go to extensions and add other functionality that isn't necessarily going to work for all boards. If I scroll down in here for extensions, I'm going to find keyboard and I'm going to find mouse. So in this case, I'm going to pick mouse, and that has just added some new categories or new options inside of this mouse category in the palette here. So I click on this. What can you do with the mouse? You can move it horizontally, that's the X. You can move it vertically, that's the Y. You can compound those to move in circles and diagonally and so on. You can turn the wheel and you can click the button. So let's take this mouse move and it defaults to 0 and 0. And how about we'll put it right in here in the move in the forever loop. And I'm going to say, let's just move, you can type in a number, you can use this little scrubber. Let's move 12 units over to the right. And how about, whoops, 6 units down. So -6 I'll type in there. And then I'm going to add a little pause in here. Let's pause, let's say half a second. I can duplicate this block, and I got a bug flying around. Let's set it back to, whoops, -12 and +6, not 112. And 6. And then I'll duplicate this. Pause. Okay, so now what I'm going to do is I'm going to give this a name down here. I'll call this Mouse Jiggler. And I'm going to download the code for that. So this is the file it's going to save, maker-mousejiggler.uf2. And this is the universal flash format, which is a file that I can just drag onto the board. When I plug it in, it'll show up as a USB drive. Actually, I'll plug it in, I'll click the reset button, it'll show up as a USB drive named Gemma boot, and I'll be able to drag that file on there, and then that file will run. Actually, I won't do that because I've already programmed this one, so pretend I just did that. You wouldn't see it without me configuring a bunch of windows. But what I'm going to do now is, if you watch my cursor here, I'm going to plug in this Gemma into USB. Hands off, and I think I have a couple seconds for it to boot up there, and then we should see the mouse start moving. Let's see. This is me moving it, so hold on. I'm gonna open a Finder window and see if it showed up. Okay, it showed up as Gemma boot, so I need to click it once. I think what happened is my heat shrink is pressing that down and keeping it held down. Let's see. Okay. So now hands off, and you can see my mouse jiggling there, right? Ooh, why did it stop? It should just keep going and going forever. I wonder if this is resetting itself. All right, let's try it on a different Gemma. Maybe I've damaged this one. I don't know what's going on with this one. It shows up as Gemma boot again. All right, hands off. So yeah, it should just jiggle forever once it starts. I don't know why it's stopping. Let's grab a new Gemma. I will upload code to it. So I hopefully still have a Gemma. I've been using a lot of them lately as I've been writing guides for the AdaBox. Okay, so there's a fresh Gemma for you. And let me grab a USB cable. You can see it now because I will do it with this longer cable. And all right, we'll plug that in. It just showed up as a CircuitPython drive on my machine, so I'll press the reset button on it. Oh, double click it, that's my problem. And I'm not good at double clicking. There it is, it showed up as Gemma boot. I think this turns green when it's in Gemma boot mode. There's some color indicators there. So now the file that I'll download, oh yeah, actually the code that was on there was a little different than what I downloaded, so it's good that I'm downloading this. Where did it go? Let's download it, and let's see. Okay, you won't be able to see this part, but I'm just going to drag from downloads. Mouse jiggler is going on to Gemma boot. Okay, it's going to flash and reboot itself. And now, if you watch my cursor over here, once it's restarted, what's going on? Let's unplug it and replug it. This is the beauty of a live demo. This is a rock solid thing, I promise, except for just tonight. I don't know what's happening. Oh, this is weird. All right. All right, thing, what's your problem? Oh, did it show back up as a... Okay, imagine that had jiggled. I don't actually know what's going on with that one. Sorry about that. Yeah, this definitely proves that it's live because I would have edited out this mess. Let me say, yeah, I don't think the... Hey, Taylor Adams asking on YouTube, is this supposed to be Ask an Engineer? We are actually, for anyone else who's tuned in and is confused, we're doing a John Parks workshop tonight because Lady Ada and PT are out of town doing a keynote for an event. So instead of my usual Thursday time, I'm jumping in here tonight to show some more of the projects from our AdaBox 007. I don't know what I've done wrong on this guy, but what I'm going to do is bail on this one and show you a much more complicated one because I'm sure that'll go great. So here you can see the Foul Fowl. So this is one of the other projects that uses USB. And I think I'm going to run this on a laptop that I have over on my workbench just because I don't want to inject the computer that I'm using to stream this video out to you with any weirdness. So the one that I have there does some real tricky stuff like opening up the terminal and launching programs and changing the desktop pattern. So I'm not going to run that on my main machine. So in fact, one of the things I want to point out about this one is that here's the Gemma that I have with this keyboard injection on it. And I'll explain what that is in a second. But if you see this jumper here, the reason I have that is that that prevents it from doing the bad thing that it does when it gets plugged in if the jumper is in place. And this, since we're programming it in CircuitPython on this one, I can plug it in, I can program it, and it won't then go and execute the code on me, because the first thing it does is check to see if the safety jumper is in place. So that's important. So let's go through this. Let's look at the code for the Foul Fowl and talk about what it does. So the idea behind a keyboard injection payload attack is that since computers trust keyboards that get plugged into them, they just think someone's on the other end typing something. And since you can do a whole lot of interesting things using keyboard shortcuts besides just typing, like launching searches on most operating systems to then launch applications, or launch a terminal and then you can do anything, the keyboard injection is able to do that using the microcontroller. So the Gemma M0 can act like a USB keyboard, so when it gets plugged in, it gets recognized as a keyboard, and then I actually have it pausing a little bit so that we take a moment after it starts. But then once things have settled down, it can start launching applications and typing things. So that's what it does. Let's take a look at the code here. I'm going to switch over to my code view, and then I'm going to try to find it. There it is. So let's make this a little bigger. Oh, let's make it bigger this way. There's a little game I got to play to scale this up to the right amount that it gets bigger for you. Oh, and that is by making it shorter. That makes sense. Okay. So let's run up to the top here. By the way, I want to give a debt of gratitude to the Rubber Ducky project by Hack5. If you look online, you'll find there's actually a product you can buy that does the same sort of thing as plugging in this Gemma M0 with this code, but it has a scripting language that makes it even easier. So check out that project. This is why I called it the Foul Fowl, because it's bad. It's a duck, Rubber Ducky. Okay, so looking at the code here, we import some libraries, and the important ones are these. Most important ones for this project are these HID keyboard, HID key code, and HID keyboard layout. Now, I'm going to assign some pins in here. This was based on a demo where you could touch some pins and have things happen. I left that in there because it might be instructive to people. But I'm not using those. The only one I'm using is this jumper on, which one is this? D2. So we'll create that board D2 pin as a button. We'll initialize the keyboard object as KBD here, keyboard. And then we're going to look through, we're going to set all the pins to be an input. And then the first thing we do is if the button isn't pressed, which is the name I left in for this jumper here, then we can go ahead and do things. If it is pressed, leave it alone. So that's how the safety works. And then when it's not pressed, what happens is it will start typing for us. Oh, is this the wrong one? Wait, let me grab the full code. Is this the full code? That doesn't look right. Yeah, I don't think I have the right one on there. Hold on, I gotta get the full code for you. And I just switched computers, so a lot of stuff isn't on this one, so I'm actually gonna grab it from our tutorial. Where is... Oop. Foul Fowl. Can you see this one? There you go. Yeah, that's the demo. That's not the full code. Here's the full code. I copied the wrong one earlier. So let's jump back to Adam. Aha, okay. So, this makes more sense. So actually the first things I did up here were to make it easy if you're going in and editing the code. I put a couple of variables up top that you can select. So I designed the payloads that are delivered in this project to be either Macintosh and Windows. So the first option can do either a Mac or Windows. The second option is just for a Mac. When you pick your operating system up here, if we select 1, because you're going to plug this into a Windows-based system. The main thing it does is I put 2 payloads on here, and for the first payload, it will do some caps lock sticking for people. I believe I have that in there because the caps lock is not a key that you can actually ask for over a Macintosh keyboard. It's actually not a key code. I think it's only done in the keyboard. Now I can't remember, but there's not a key shortcut that you can use that's inside of the ANSI definition of characters you can type on Mac, but on Windows you can. You can actually call keycaps and turn it on. There might be a couple of differences. Okay, so let's look at those. So for the payloads, the 0, this is the first one. The first payload is a little simpler. So I have this one selected here, and I'll have Mac selected for when I run it on that machine over there in a minute. So same stuff I mentioned before. We'll instantiate the keyboard. We'll check the pins. And since I only wanted the payload delivered a single time, I start with this variable called payload delivered at 0. After we run through the script, we set that to 1, and then the thing won't keep repeating itself over and over again. So we start off with not having been delivered. We sleep for a couple seconds after we've plugged it in to make sure that it's settled down and the computer is ready to receive key commands from this, what looks like a new keyboard to it. And then in this, if you look here, let's see, where do I select? Yeah, okay, so these are the different functions. So at the bottom of this, I'll lay out what we're running, but I made a bunch of these different functions that we can call on. So first one is this launch terminal. So based on it being on Macintosh, we do it one way. Based on Windows, we do it a different way. So if that operating system was at a 0, we're going to press, this is the key thing, this is the key code followed by the name in the sort of USB ASCII key code or ISO key codes, I forget which one there, that stands for, on any operating system, there's a button that has a window on it, or on in the Apple, it's got an Apple on it. Take your pick on Linux, you've probably got custom caps. But there's a button that calls some sort of GUI level thing. It's like hitting the Windows key on Windows. And on the Mac, if you press that button and the space bar, it pops up a search window by default on default installation. And as you may guess, these things kind of need to be tailored for the target, because people can do weird things on their computers that means that default behaviors are no longer there. But on a default vanilla Mac, this will launch a search. We then press this release all. That's like you taking your fingers off of those 2 keys. And just kind of for debugging purposes, I blink LEDs as each of these things happens, which you could turn off if you wanted. You could remove these lines. And then I sleep for some short delay. I think it's a quarter second I set up here, 0.25. And then we have this search window open, and this is actually going to be the same on Mac and Windows, just how we call that search window differs. But here we've got a search window open, and then we're going to use, instead of just holding down key shortcuts, we can have this thing type. And someone asked this the other day, how fast does it type? I actually don't know what we've got some reasonable typing speed sort of built into the library. You could probably go in and change that if you wanted it to be faster. If anyone in the chat knows, there's some people who've probably tinkered around looking at the CircuitPython HID library. How fast does it type? How many words per minute? That's a good question. But this types fast, but sort of at a normal human rate. You'll see in a minute when these get typed in for us. So we're typing in the word terminal, pausing, and then pressing the key code enter and releasing the key code enter. So that's type the word terminal, press enter, release. That will launch the Macintosh terminal application. Now, the next thing I do is so focus will be shifted over to the terminal application automatically. So once that has happened, I then run the new, which is this key code GUI and key code N. So that's Command N. That pops up a new terminal window. And the reason I do that is if something was already happening in the terminal, if terminal as an application is already open and there's a terminal up, who knows what's happening in there. So when we either open it from fresh or switch to it, we're going to get a new instance of a terminal. That's what Command New does. And then we start typing stuff, and this is the fun thing. So what I have here first is an AppleScript. So AppleScripting is also called Automator. I think they're the same or closely related. And these are these system-wide conveniences that allow you to script or create macros at kind of the system level. So this OSA script runs, here I'm telling it to set the volume. So it'll literally set the volume up. I picked 7. So someone might have the thing on mute. This is actually going to change the volume on their Mac up to 7. We press enter, and then I type in this command into the terminal, which is say hello friend, and I'm running it at a slow speed. I forget what -R is, but I think 20 is like an unnaturally slow speed. So you'll hear that in a minute. It's creepy. So say is an old Macintosh command. It's been around forever and ever. Try it right now if you're on a Mac. Say, quote, some words, close quote, hit enter, and one of the text-to-speech voices is going to say something out loud to you. So that happens. That freaks people out. Then we wait a moment. I'm going to clear the terminal, and then I'm going to type just echo, which doesn't do anything. It's not a command, but it will throw these words up there twice, in fact, in their terminal. It says, try to be more careful what you put in your USB port. So it's meant to be a warning. Now let me take a moment to say, as cute as this project is, and as these little Gemma M0s are, this is potentially really dangerous stuff. So don't ever plug in something like this on a computer that is critical for security, healthcare, power, nothing that could mess someone up, nothing that's a sort of vital system would you want to do this on, unless you're a really bad guy, and I don't want you here anyway. So, you know, part of the question on why am I even showing this, why did we include this project, is people should know about it. This is the sort of thing that someone could pick up a USB drive that looks innocent, say, hey, free USB drive, plug it in, and boom, you've got a rootkit on there. So you've got to be careful about what you plug into your USB, and that's part of the reason that we did this project. But it's also really fun for pranking your friends. So do so, but do so carefully. So here you can see now I have this else if, elif statement, which says if the operating system is set to 1, which was what we set up at the top for it being Windows, then we're going to press the keycode GUI, and that actually goes right to Windows' little run command bar. And then we're going to type in the word Notepad. So we're not actually using a terminal here. I made this one a bit simpler. We just launched a Notepad, and then inside of the Notepad, we type out the word hello friend. And we also do a big giant ASCII version of it, which looks messed up here, but it looks kind of cool when it shows up on a machine. Ideally, you do it in a monospaced font, but I'll leave that as an exercise to the viewer. Now here's some other functions that I've created. So here's one called download image, and this is one of the ones that runs in my payload that I deliver on the Mac, if you select that one. Excuse me. And this one will launch. We've already got the terminal launched, so this is all happening inside of the terminal. This will change the directory that your local current directory is to the desktop, because I figured that's going to be there, right? You're guessing a little bit what's on someone's machine. Desktop, pretty likely to be there on a Mac. So we go to the desktop. We list the contents of the current directory, and that is only to look like hackers are on your system, because when you see a list of stuff show up, people will freak out. So that was just for the effect of it. We don't really need to list the contents. Then I'm using a curl command, and curl can run out to that internet of ours and do stuff. In this case, the command I have is going and downloading an image. So it's downloading the AdaBox logo, actually. You could place an image anywhere at any URL that someone can get to from that machine, and that's what you would suck down. I happen to be saving it to the desktop as hackimage.jpg. And then we wait a moment for the download to finish. So I have this sleep for 16 seconds. Seemed to be more than enough time for the image to download. You could tune that if you're doing this to someone who's in your own house or office. Figure out your optimal time for that. And then I'm also changing the permissions on that image because we want to allow the system to use it as a desktop background. So the system needs to be able to have access. So we basically set all rights, all permissions, read, write, execute for all users on this image so that anyone can use it. Okay, so that's the download the image portion. Here's a function that is the replace the background. And so again, this is mostly a really long-ish AppleScript. And you can see a lot of AppleScript is written kind of in plain plain language, plain English. And after I fought with the syntax on that for probably an hour and got it to work, because I had to put a lot of these little escape commands so that it wouldn't interpret quotes and things like that. Once I got that to work, though, what this does is it switches the desktop background of the current desktop. I think I tried to have it do it for all, and that was inconsistent. The command tries to tell it to switch all backgrounds if you're a multi-desktop user, to that image that we have saved. And then I kill the dock. So killing the dock actually refreshes, is a way to kind of sort of force the image to refresh on the background. It's obscure and weird, but it seems to work. And then, let's see, do I do the... I can't remember if I'm pressing... Yeah, okay, right here. So new function is this hide everything. This presses F11, and on a Mac, F11 shows the desktop. It scatters all windows off into the edges of the world, and you're just going to see the desktop. So it's a chance to, in case the person you're attacking has everything covered up, this is going to show it. Yeah, so in the chat, Dastel says, never plug an unknown USB drive like when you find lying around into any computer. This is absolutely right, and this is a big part of this project is meant to illustrate that. I'm a big fan of the TV show Mr. Robot, and there was a attack like this, I think in the first season, where character Darlene drops a bunch of USB thumb drives that look like they're promotional, and they say, like, download so-and-so's new album outside of a prison. A prison guard happens to walk by and pick it up, like, hey, free album, and he goes in and plugs it into his computer, and it has I think a rootkit that tries to run itself. He's actually savvy and yanks the thing out before, so good for the security guard, but that's a nice example of this type of hack and why it's dangerous to plug in a USB drive, because they could be running something like this. Okay, so those are all the functions, all the things that we can do. Now here's the meat of the program. When it's been plugged in, it runs this. While true, it checks for the presence of the jumper. So I have my little jumper grounded on D2. If it's there, it doesn't do anything. It'll give us a little print statement if you're looking inside the REPL or a screen or something like that, but nothing happens. And it finishes, it says the payload's been delivered, which was kind of a lie. There was no payload, it just stops right there. The other option is that the jumper isn't in, and this is where the fun begins. So here I look at the choice that you've made for payloads. If you chose payload 0, then we just run that function called launch terminal. If your payload variable was set to 1, then we launch the terminal, download the image, replace the background, and hide everything. So you can see here I named my functions very clearly so I could remember what I was doing with them. That'll tell you exactly what's going to happen when this payload gets run. So that is it. So let's go and run this over. I'm going to set that machine up on my desktop. I've got a little laptop over there, and see if we can't wreak a little bit of havoc. Let me switch. I'm going to go to this main cam for a second while I head over there. And let's cross our fingers that this one works better than the mouse jiggler. That one was mysterious. I don't know what was going on. Only thing I can think is I was plugging that into a USB hub that I think is also plugged into another USB hub. So probably some flaky things were happening, and I was overdrawing current or something, or just not communicating well with the machine, so it couldn't, excuse me, it couldn't execute that mouse jiggle for more than a couple tries. That's my guess. We'll try it on this one. How about that? Because I'm a glutton for punishment, so I really do want to try to make it work. So let me, sorry, I was soldering some stuff and things are in the way. And look, I've still got all this great AdaBox stuff from the unboxing last night. The box, puzzle from DigiKey, my 2600 magazine. I haven't even gotten a chance to look at this one yet. I used to love 2600 when I was a young phone freak. I didn't just admit that. Okay, so let's see. I'm going to hide this for a second while someone's going to use some sort of audio forensic analysis and know what I just typed in as my password, I'm guessing. All right, so let's move this cable here, and I will go to a fresh desktop, fairly fresh desktop. And let me turn off some notifications. Oh, you can see what my, whoops, code was there. Let's wipe off this screen too, because I think you'll get a bit of a reflection. And one thing I want to do, though, is I'm going to make sure that my background is not set to that logo, because we won't see it change. I was testing it on here. And while I do this, I'm going to zoom my camera in so that you can see a bit better what's going on. That's a bit better. Yeah, sorry for filming a screen with a camera, but I didn't want to plug this one into the system. So let's go to, what is it under? Where is the backgrounds? Is it desktop and screensaver? I think it is. Okay, so let's just change to a color. How about solid mint? Okay, let's, why not, try this out first with our mouse jiggler. So I'm plugging that in. Oh, is this one, I think? This is the one I think the heat shrink is pushing down on. No, that just doesn't. Oh, there it goes. Oh, see it? Okay, so this is one I had programmed earlier. Sorry, I can't get it to quite focus. You can see my mouse there every, I don't know, 5 seconds. I think I have it set to, I'll put my hand here so that it stays focused. Tricks to fooling autofocus. So there you go. So that's just, you know, I'm not touching the trackpad. I can zoom out a bit if you don't believe me, but that's just this little mouse jiggler. You can just see it right there moving back and forth. So that being plugged in is doing that. Really fun for a prank. Put that in the back of someone's computer and shenanigans. Okay, now let's take a look. I was messing around with, let me, oops, did I just turn that one off? Ooh, it didn't notice that I accidentally tried to turn it off. Thank you. Let me switch inputs for a second over to this guy. So I was playing around with, we have these really tiny OTG on the go adapters that go from micro USB to USB-A. I also put some Kapton tape on the back here because there's nothing to prevent you from plugging these in upside down because it doesn't have a full USB housing. So I didn't want to short stuff on the inside of the USB port. But this, let's see, does it go in? Yeah, just like that. This would be a really tiny little package that you could plug into things. So for now, though, let's take our little cable. And I just realized, was I at, I don't know if I was at full, I was not on full screen for that. So let's do that mouse thing again, much bigger. Sorry about that. I was looking at the wrong monitor. I have a lot of monitors to monitor, all the monitors. Let's not give you a glare. And we'll zoom. Okay, and I will plug in this one. Yeah, for some reason this one's, I think it could be the heat shrink on this. Is actually, when it gets plugged in, it is, I think, showing up as Gemma boot, because I think the reset button is squozen down a little by my heat shrink. All right, so that's, you can focus, come on, there it goes. All right, that's better. That's a bigger view you can see now. So that's just this guy being plugged in here causes that cursor to go wiggle, 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 and stop. Again, like a lot of these projects that are meant to prank people, you can get a lot of mileage out of using restraint. So if you tell this thing to wait, let's say, half an hour before it does it, 2 hours, it's just annoying, but not so annoying that someone will track it down. Sorry, I just realized this big light is sitting here. Get that out of the way. So it will be harder for someone to sort of focus on solving the problem if you make it more intermittent. That's kind of a similar idea for the Annoy-O-Matic, which is a little beeping alarm guy that we built. Okay, so now I've got, here's my, excuse me. This is my Foul Fowl with the jumper in place. So I'll plug that in with the jumper in place, and we shouldn't see anything happen. Let me show you a new Finder window here. So it just shows up as Circuit Pi. And I'll just confirm this has Foul Fowl on it. I just made a file on there called Foul Fowl. Okay, so nothing happened because it's jumpered. Now I'll unplug it, remove that jumper, and now when I plug it in, watch out as, let's see, does it go in? Yeah, just like that. So that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, you can focus, come on, there it goes. All right, so that's, starts executing. So there it has just run terminal. Something went wrong there with that. I'm going to try that again. All right, we have an off switch on there too, which is a convenient way. I'm not sure why it failed to launch the terminal. Okay, so launch the terminal.
Hello, friend.
That's super, super creepy. I just typed, try to be more careful, what you put in your USB port. Okay, so now we're safe to, let's go ahead and put our jumper back on. Now we'll change it over to the second payload. So that's the first payload, and that one is a little more benign. Give me 1 second, I'm just gonna switch on my Discord over here so I can see the chat. Where are you, Discord? This is gonna be a, yeah, okay, here's the, I'm gonna pop open the YouTube as well. I'm just gotta turn off the sound. Because I want to know if you're screaming at me, we can't see the window. Okay. Good. Let's change the top chat to the live chat, and there we go. Okay. Good. So I'm not going to switch over to the other machine, but what I'll do on this one, I can just tell you, is I'm going to open up the main.py file that's on here. Give you this camera view once more. And I'm going to just change the payload variable from 0 to 1. So here I'll find the CircuitPy drive, and there's this main Pi. And, you know, I'm going to zoom in because you're going to see in a moment we're going to do the full payload on here. So now I'll switch the payload to payload 1 and save this. Now, if I didn't have the jumper on there, it would have just immediately gone and done all of its bad things. So that's, every time you save, it re-executes or it restarts the program that's running on there, the main Pi program. Okay, so I can quit Atom now. And that's just the text editor I happen to use. You can use the Moo. You can use any text editor that does ASCII, any coding environment you like. Notepad, text editor, they'll all work for you. So now I'm gonna, excuse me, turn this off. Take off the jumpers. And, oops, wrong camera. I bet someone was yelling at me about that. Thank you, Katney. There it is. Okay. So you didn't miss much. All I did so far was use my text editor to save the change in the variable. So now it's going to do the full payload when I turn this on. So here we are, kind of minding our own business. This thing suddenly deploys its payload. So we wait a few seconds. Launched terminal. It made the new window.
Hello, friend.
Did that. Oh, it's relaunching that.
Hello, friend.
Okay, so there it just listed the contents of that window. It is downloading that, so what it has done here is that curl command, which downloads, try to get that in focus, I'm sorry. All right, that's a little better. It just changed the permissions, and now it has changed my background, which was that blue, and in a second it's going to refresh the dock and then move everything away. So that's it's actually the AdaBox logo. You can't quite see it. It's very low contrast. It's gray on black on this one. But that is the full payload running. So check this project out and see if you can come up with interesting, fun, and devious things to do with your Gemma M0 and this HID hack. In the case of the rubber ducky from the Hack 5, there's a whole scripting language that makes some of this stuff easier. So I'm really either using keyboard shortcuts that run on the whole system-wide or per application, a mix of that with terminal commands. But it's definitely conceivable that you could come up with your own scripting language and have separate payload files. And that's how it works on the Hack 5 rubber ducky. There's a small text file that contains just the list. If you think about what was at the bottom of my code, where all I said was open a terminal, type a thing, close the terminal. That's the sort of level of the scripting language that you can use, which is great. It makes it a lot easier for a lot of users and office pranksters, hopefully, and not nefarious people. So yeah, I saw in the comments someone said you could definitely mask this as some other USB thing that someone thinks they're plugging in, I don't know, a USB fan or a USB coffee cup warmer, coffee mug warmer. Anything that gets plugged into USB, if it's a data cable and not just a power cable, you could insert this up inside of the internals of the mug or whatever it is, and get someone to execute malicious code. So I think it's a very good teaching moment, and I hope you have fun with that. We'll be interested to see in the forum and in the chats the kinds of projects that people come up with using that. Okay, so let me switch back over to this machine here for a moment, and back to the guide. I'm also going to take a sip of water because I'm apparently choking to death. All right. Pardon me. Sorry. I should have turned the volume down. How's that? I had a funny moment with that yesterday on the live stream where I came out off after the video to talk to everyone for about 10 seconds with my mic turned off. So all you lip readers, that's your opportunity to get the good stuff. Yeah, the hello friend is definitely pretty creepy, Andon. You got that for sure. And there are a lot of voices, a lot of voice choices. Check it out. The say command is really fascinating on the Mac. So let me pull this over here and make this size work a little better for this window. Yeah, that's good. I close all those. So going back, that is our Foul Fowl. So going back to the AdaBox, I mentioned the other project that uses this HID is this SAR Tuning Knob. Now, this one, I'm going to launch a window where you can see this. The way that I decided to use this inside of, I think it was Cubic SDR was the software I was using. Cubic SDR uses the bracket keys to incrementally tap forward and backward through a frequency range that you're trying to tune in. And so what I decided to do was add the potentiometer to the Gemma. And this was this thing I came up with using these machine screws that I was so excited that it worked out so well, that the fit was just right. You can bend the legs out on the potentiometer and then screw them right on there. So we get this neat little package of, doing that backwards in the camera, this little Gemma with its little knob on there. And so what I'm doing is I'm actually reading the analog values of the potentiometer. So the way the potentiometer works is that it's on one leg it's touching ground, on the other it's touching positive voltage, in this case 3.3 volts. And then the middle leg is reporting out signal, which is the voltage that's coming to that pin based on moving the wiper of this variable resistor, this potentiometer. So when it's in its center position, which is that, it reports half of 3.3. I can't do that math, but about 1.125 or something. I don't know what that is. Someone do that. At that halfway mark, it doesn't type anything. and then I'm just sort of clamping voltage ranges when it gets over the next subdivision. I subdivided that by 10, I think. When it gets past the next subdivision, it will start typing forward brackets with a certain cadence. And then when we go to the next range, it types them with a faster cadence, faster, faster. And then as we head back the other way, it's the backwards brackets. So this seems to work pretty well. I'm going to plug this in now, and I'm going to show you inside of a window. I can go back actually to my editor here. And I'll just clear some space down here at the bottom. Kattni was helping me with some of this, and as we were testing these things, we both realized you need a little safe spot down at the bottom of your code. You could put a little comment out block like this. That's where you leave your cursor when you plug these things in, because it may just start typing, which can screw up your code if you forget and leave your cursor somewhere. So let me get the long cable here. I still am not sure what's going on with that jiggler project. That's going to bug me. So when I plug this in, you can see it's at the halfway mark, and so it's not typing anything. And now it's typing these brackets at whatever this cadence is. And you can see as I turn the knob to the right, it's faster and faster and faster and really fast, zipping along. And I'll go, let me stop that for a second. I'm going to clear this out. Now you know what, I'm going to do a new document, because my editor is going to do things when it sees a open bracket. It's going to try to add a closed bracket, which looks weird. So this one instead won't. So you can see when I go to the other direction. Oh, this one's doing that too. Gosh. I would have to turn off syntax highlighting or something, or syntax. Yeah. All right. So that's why it's adding those there. This should not be the case. I'm going to just do it for a second inside of my search bar on my browser. So you can see this window right here. And the only thing that's happening is that the automatic search is trying to... Oh yeah, look at the search results for bracket, 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 bracket. Ooh, this is kind of fun. It's kind of like making little wavy artwork. All right, I'm going to get lost in this for a few hours. Ooh, it's never going to stop. Let's make that type real big. Oh, it failed. Did I flood the buffer overflow? Oh God, and now it's up there. Okay, so I'm having too much fun with this, I'm sorry. That's the sort of thing that you can do with your Gemma M0 and a potentiometer screwed on with our little machine screws, which can then act as a keyboard shortcut for your software. You could do up to 3 potentiometers on one of these Gemmas. It would be difficult to do the same trick here where we have it plugged in without actually running a wire across the ground from one. But since you can read in 3 potentiometers, we got 3 analog ins, right? Am I right? I think we have 3 that work. Yeah, because A0 is funny on output stuff because it's also a speaker, but I think it works as an input. Someone correct me in the chat if I'm wrong on that. But anyway, you could do some interesting things with, if you want to make an Etch-a-Sketch, you can have your mouse X and mouse Y based on that. Very simple stuff that you can do, all based on the power of the M0 chipset and its ability to be a keyboard or a mouse, and the CircuitPython HID libraries make that really easy to use. Let me open up, in fact, for a second here, the code for, let's go back to our, I'm going to switch over, excuse me for one second, to the browser again. Oh man, I made that real big, didn't I? There we go. If you look at the code for the SAR Tuning Knob, let me make this just a bit bigger so it shows me the... There it is. Build the tuner. Oh, I have this all on one page, that's why. Is this the main code? Yes. That's the code. That is all there is to it. So we import some libraries like before. so that we can read the analog inputs, deal with time, and then write out the keyboard commands. And then here you can see I wrote this function called spam key, and it's the things that it sends out based on this number of, I'm going to copy this code and put it in my text editor so you can read it. Where'd Adam go? You can see it, but I have hidden it from myself. There it is. So here you can see I've got this list, and this is just right bracket, right bracket, right bracket, right bracket, right bracket, space. So space, that's what it hits when it's in the middle. Do I have it doing that? I think that was important for some reason. I don't remember why. I don't think I'm actually pressing that, am I? I'm going to have to review my own code here. And then the spam rate. So the spam rate is actually, these two things are what's changing as we read the voltages. On the knob, we are going to type in whatever key we're at for that bracket after remapping this. And we're going to do it at the rate of whatever our spam rate is set to. So that is the third project that we have using HID. And there are a lot of other projects that we've done in the past using this keyboard output. My camera switcher box, my little button box over here, this guy, when I come over here and click this thing, let's see if I can fish it out from a bunch of wires. There's a synthesizer in the way. Hey, there it is. All right. That guy there. Oh, I'll go to this camera. This button box, this is a lot of people ask about this. This was based on a project that Noe and Pedro did using, I think, some arcade buttons and a 3D printed enclosure. Or maybe they also did one with a mechanical keyboard, a small mechanical keyboard. But this is just a Feather board that I have on here, CircuitPython. It's a Feather M0 Express. And I've got 6 arcade buttons wired up to it. So when I press those, it just sends a keyboard command that, let me go, if I have my broadcast software selected, it will just hit a keyboard shortcut to switch between camera views. And so that's the secret behind that switcher box. It's just an HID thing. So many things are HID-able. I'm trying to think. We have some others. My pinball project that I did also, if I recall correctly, CircuitPython, HID stuff. So big fan of it. So I hope these projects get you interested in checking out some of the AdaBox 007 keyboard and mouse masquerading things. I don't know what's going on with the jiggler. I got to fix that. But that is all we have. I want to thank everyone for coming out to the chat in Discord and YouTube. The discount code is still good. Is Itsy Bitsy? Yeah. All right. So I have another coupon code prepared. It won't do anything differently for you, but just in case Itsy Bitsy isn't the code for you tonight, we have quack quack, quack quack. Get it? Foul fowl, quack quack. All right. Someone said, whoever looks through the site analytics on search queries is going to be scratching their heads. Yeah. Who was searching for bracket, 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 bracket? I don't know. People love ASCII. All right, well, let's pop over to the chat for a second and see if we've got any thoughts or questions. Oh, thank you. Yeah, thank you for coming out. I'm glad that was informative. I have become a big fan of HID just because it's become so easy to use. Years ago, I wanted to do this stuff, and it was just so complicated to program the sort of tool chains you needed to program HID devices to do something. It was prohibitively slow to iterate on, and now it's become so easy to iterate on these things that you can get up to a lot of trouble, but you can also do a lot of good. Clearly, a lot of assistive technology things can benefit from having easy-to-use interfaces that talk to a computer with the press of a button. So I think that this is a nice option for assistive technology projects. And we look forward to hearing what kind of things you do with your Gemma M0 in the AdaBox 07. Or even if you didn't get the AdaBox, you can still go check out those tutorials. Good. Now if you make arrows, what quack? That's a good question. Well, thank you, everyone. And I will not be on the regular time tomorrow because I filled in here for this one tonight. So no John Parks Workshop tomorrow, but I'll be back to my usual time on next week, Thursday at 4 p.m. Eastern Standard Time, 1 p.m. Pacific Standard Time. So for Adafruit Industries, this has not been Ask an Engineer. This has been Ask a JP's Workshop, I think. I'm going to play out some of my funky music. Bye.
Wow.